Uh, Hello, this is Group 4 GFW0001 AI project. Our project is an AI compatibility predictor. So there's 11 of us in our group, and myself, the leader. My name is Navinraaj from engineering faculty.
So hi, hello, my name is Afiqah. So for the executive summary, AI Compatibility Predictor from Data to Love. So basically our purpose is to estimate the compatibility using AI and personal data. And then for our method is a machine learning model analyze traits like personality and hobbies. And then for the output, we want to provide an easy to understand compatibility level, which is either high, medium, or low. And then for the demo, is a functional display app built with MIT App Inventor showcases the AI in action.
So hi, my name is Roslyn Sahira, and now I'll be talking about project overview. So this project is built on the idea that compatibility isn't just something random. Instead, it's shaped by patterns like our personalities, hobbies, habits, and the way we communicate. By observing this pattern, our AI compatibility predictor estimates how well two people might match. The goal here is to help users navigate the talking stage in a way that feel more intentional, clearer, and more meaningful. The system also gives a simple compatibility score that acts as a guide. With this approach, people can form better, more informed connection without having to guess.
Hello, my name is Wai Xun, and now I will be talking about our AI problem statement. So, as a human, we are constantly facing a lot of challenges that require smarter and faster decisions. So, a lot of modern relationship apps and online matching system mostly rely on surface level details such as photos or short bios instead of focusing on real compatibility built on values, personality, and also shared interests. So because of this, people often form connections that lack a long term of understanding or balancing, leading to mismatched relationship and also emotional dissatisfaction. So we think that there is a need for an AI-based solution that can analyze simple personal information and behavioral traits to estimate how well two individuals complement each other. So to offer a more thoughtful and also meaningful compatibility assessment.
Okay, hello, myself is Navinraaj. I'm the leader of Group 4 for Artificial Intelligence for Everyone. So I'll be talking about the objectives of our AI compatibility checker. So what it does is it works to develop a machine learning model that can predict compatibility between two users after they have engaged into first contact, meaning they have already shared their thoughts and shared their hobbies and later on, and they don't know whether they are compatible with each other or not. And then at that case, what they can do is they can use our AI compatibility checker, at which you can put in all the details, what are the things that you are both compatible with, put in the age gap, see whether both of them are extrovert or introverted, and then later on, you can get your summary on what you want to do. And then it also is a tool to build a user-friendly interface for data input and output visualization. We try to make up with an idea at which we can make it very much user-friendly. It's very much easy to use, and to show how AI can assist in social and emotional analysis through quantitative methods. We also did a bar chart, which will be later on shown in the one of the last slides, to demonstrate AI workflow steps from data collection and pre-processing to model training and prediction. We have successfully made a good running product that can predict compatibility. Thank you.
Okay, as for data collection, we have created a small data set of 60 sample pairs. Each pair has basic information such as do they share the same hobbies? 1 is for yes and 0 is for no. Do they have similar personality? Do they have like the same music taste, the age differences, and also communication score either 1 until 5. And each pair was given a compatibility score from 0 until 100%. As for data pre-processing, before training the model, the data was cleaned by first converting yes or no features into 0 and 1. So as for 0 is a no and 1 is a yes. So and then normalizing numbers like age differences, removing outliers, and then splitting the data. 60% is for training, and then 20% is for testing.
Now, this is the system design or what the flow of the app will be like. Once the user has started the application, they will be asked to input some of their data like name, age, hobbies, personality, music, and maybe some of their other personal interests. Then the application will process the following data and convert it into numerical form so that it can be sent to the AI model or teachable machine. The AI model or teachable machine will then process the features between two people and predict the compatibility level between those two people, whether it is high, moderate, or low. Once the compatibility level has been received, it will display the result score and provide a feedback message to the user before ending the whole process and ending the application. So this is the user interface. Once the user has entered the application, they will have to first complete their profile by answering questions regarding to their personality, character traits, and preferences. Then the output of this model, it will predict one out of three compatibility levels between two people, which is either high, more than 80% compatibility level, moderate, 50 to 79%, and low, which is below 50%. So there are a few ways that we can use to get the compatibility level or find our potential match. The first is compatibility quiz, where we will invite a person that we are interested in and ask them to answer the same quiz that we are doing. Second is manual data upload, so we will send a form to the person we're interested in, and then we will extract their data or their responses, and the data will be uploaded into the application so that the AI can process it and give us the compatibility level. And lastly is online search, where we can just browse the app simply for other users that also have the high compatibility scores with us. So the user interface first is machine learning, which features engineering as it converts raw data into a more structured format that machines can easily interpret. Then is supervised learning, where it trains AI by using examples of successful and unsuccessful couples to learn traits that indicates compatibility. Then is similarity analysis that measures how similar or different data points are to identify compatible matches. Then the second one is natural language processing, where it enables AI to analyze open-ended or free text responses, interprets user input to generate meaningful insights and explanations, like why two individuals are compatible or not, the key factors that may affect their relationship, and also guidance on how a couple can improve their compatibility.
Hi guys, my name is Kivakshini and today I'm going to do methodology, which is the modeling technique. Number one, it starts with neural networks, which is also known as deep learning. It is also known for effective and for identifying complex relationship patterns and behaviors. Number two, Siamese neural networks, cosine similarity and k-nearest neighbor scannen, which includes recommend users with high compatibility and identify and match users with similar relationship patterns. Number three, transformer-based models, which enhances AI's ability to communicate and explain compatibility results clearly and naturally. And last but not least, sentiment analysis and sentiment analysis and topic modeling. Sentiment analysis and topic modeling, which provide deeper insights into emotional tone and key themes from an open-ended response. Thank you.
So these are the two AI training tools used. The first is Google Teachable Machine, which and the Orange Data Mining. So for the Google Teachable Machine, first we have to import the CSV dataset, and then we have to select tabular classification project type and input the features and the target variables before training it using decision or logistic regression. And lastly, we will export the train model for prediction. And meanwhile, orange dataset, we will load the dataset and we will use the dataset to select columns, and then we will test and score and use the prediction widget. After that, we will train multiple models like decision tree, random forest, and from there we will compare the accuracy before choosing the best performing model. So the user interface design tool that we use is MIT App Inventor to input the fields for name, age, hobbies, personality types, and more. Then we also have a button which predicts the compatibility, and it also has an output that shows the compatibility score and feedback messages after the AI had processed the data. So this is the analysis steps. The first is the dataset will be imported, then it will be checked for any errors, and then it will prepare features based off the inputs, and a model decision tree will be chosen, whether it's KN or logistic regression. Then the model will be trained by 80% of the data it received, and the model will be tested using 20% of the data, and we will evaluate the performance or the accuracy, and based off of that we chose the best model for the predictions.
Moving on to the next part of our presentation, let's dive into our solution prototype demonstration. This simulation is designed to clearly explain how our proposed compatibility match system would work in practice. The process is broken down into 3 key stages, as you can see on the screen. First, we have dynamic data input. Here, users interact with the system in two main ways. One is through hobby selectors. These are interactive smart chips that let users easily toggle share interest on or off, such as music or travel. The other is through granular controls, which include intuitive sliders. User can set precise variables like the acceptable age gap or the importance level of a specific interest on a scale from 1 to 10. This gives them fine-tuned control over their preferences. Second, this information is perceived by our AI. Once the user provides their input, the system begins a real-time analysis, comparing this data against our extensive training dataset to find out optimal measures. During this phase, we provide visual feedback, a dedicated loading animation that visually represents the AI pattern matching process. This makes the system feel responsive and transparent rather than a black box. And finally, the user receives a comprehensive result. The outcome is presented in 2 clear formats. One is a straightforward compatibility score, clarified as high, meaning above 80%, moderate or low. This gives an immediate at a glance understanding, but more importantly, we provide AI insights. This is a broken down that explains why matches were successful. For example, it might highlight that shared hobby indicates strong bonding potential. This adds a layer of understanding and deep depth beyond just a numerical score. So, in summary, this prototype demonstrates a user-friendly journey from flexible input through intelligent AI processing to insightful and explainable results.
Okay, we will now demonstrate our interactive prototype. As you can see, we prioritized a clean modern interface to minimize the user's friction. So first is the input phase. Instead of tedious manual typing, we implemented interactive smart chips. So that allows the user to quickly toggle the interest between them, and we can add more. But for the basic one, we just put simple, the most common hobbies that 2 people have. We also capture key vectors like the personality type, introvert or extroverts and whatnot. And then later on, we try to look into the quantitative metrics like age gap. We also added interest level slider, so allowing the user to intuitively quantify their initial attraction on a scale from 0 to 10. From 1 to 10, my bad. When the user clicks predict compatibility, the system enters the processing phase. This visualization represents the AI vectorizing these inputs and comparing them against the successful patterns found in our dataset of around 30 couples, 29 couples, if I'm not wrong. Finally, the output goes beyond a simple score. It classifies the match as high compatibility or low compatibility or not compatible at all and whatnot. And then it provides an explainable AI insight. So telling the user why the match works. Like for example, it will tell strong correlation found between their shared hobbies and their optional age gap and whatnot. So this is our simulation, and this is how I demonstrate my AI compatibility method. Thank you.
So our results and finding is the first one, demographic constraints. So we had restricted our analysis only for the ages between 21 to 50 to ensure that everyone on the application
Okay, we will now
is only
demonstrate our
looking for
interactive
serious and
prototype.
long-term
As you can see, we
commitments. The second
prioritized a
is
clean modern
quantitative
interface
findings. By
to
removing the
minimize the
outliers, which is
user's
below
friction.
21 and above
So
50, we were able to
first is
achieve
the
a
input
higher
phase. Instead
consistency
of tedious
and
manual
the
typing,
system
we implemented
effectiveness
interactive
inputs
smart
from
chips.
0 to
So that
100%
allows the
still
user to
within the
quickly
mature
toggle
demographic.
the interest
And the
between them,
third
and
one
we can
is
add more.
qualitative
But for
discussion,
the basic one, we
since
just put
the age
simple,
restriction
the most
aligns
common
better with our
hobbies that 2 people
objective
have.
of
We also
intentional
capture
dating.
key vectors
So
like
this
the
tool was
personality type,
able to
introvert or
provide a more
extroverts and whatnot.
value-based
And then later
icebreaker,
on, we
which
try
is
to look
relevant
into
in the adult
the
age group.
quantitative metrics like age
Okay,
gap.
my name is Alya.
We also
Here's
added
the overall
interest level
conclusion
slider,
and future
so allowing
direction.
the user to
So the conclusion
intuitively
is
quantify their
our
initial
projects
attraction on a
combines
scale from
between
0 to
emotion
10.
and AI,
From
analyzing
1 to 10,
personal
my bad.
data to estimate
When the user
compatibility.
clicks
While love is
predict
hard to
compatibility,
predict,
the system
AI can
enters the
support
processing phase.
patterns
This
behind
visualization
human
represents
connections,
the AI
helping us
vectorizing these
understand
inputs
relationships
and
more
comparing
clearly.
them against
The
the
results
successful patterns found in
are
our
based on patterns and
dataset
probabilities,
of
not
around 30 couples,
absolute
29
truths.
couples if I'm not wrong.
So data privacy
Finally,
and
the
user
results, the
concerns are
output goes
very
beyond
important.
a simple
So
score.
for the future
It
work,
classifies the match as high compatibility
the
or low
system
compatibility or
could
not
be
compatible at all
improved
and whatnot.
by adding
And then
more
it
diverse
provides an explainable
data
AI
to make
insight.
it more
So telling
inclusive
the
and by refining emotional analysis models to make predictions more accurate. This way, AI can support people in understanding relationships better while still respecting privacy and ethical considerations. So that's all from us. Thank you.
That's all from us. Thank you.